Welcome, I'm Bill Wake. We're here working on a programming language interpreter and compiler for a language named 10th that's an imitator of 4th. We're doing test-driven development and we're working in ARM64 assembly language. We've done most of the compiler interpreter stuff, except we haven't really implemented input yet. So we're working on turning our terminal into a raw mode input so we can get characters in as we want. We did a lot of research yesterday, and I think we're ready to start doing some implementing today. So let's make that our official task here. All right. Now, I think, well, we created a file yesterday. Let's go find it. Was it in IO? Okay, yeah, so I'm assuming we'll work in IO, that we've already got some things in on those lines. I just created IO tests with nothing in it. Okay, yeah. All right, so our to-do, I think this is what we learned yesterday. So there's a terminal IO structure, term iOS, that C uses. Now, I'm mixing them up now. Well, whatever it is, there's a terminal structure that there's one level that C uses and one level that Unix level code uses. And we're going in at the Unix level. We managed to dump this, so it consists of 4 flags. That's these first 4 lines. Well, four sets of flags, I guess. And then I think it's 20 bytes or 22 bytes of character data. That looks a lot like 4 times 8 is 32, 34 characters. Seems a little higher than I expected, but now the flags, they're one set's like input flags, output flags, local flags, and some other flag. I don't remember what it is. Notice the difference between these two. We had a C program that dumped them out, and we can see that the first 2 cells are different, 026B. Then this is a little different. Then this is the same, and this is different. Now, these 2 are the 2 that really control things. So one's echoing. Do we echo a character when we're reading it? And the other is, it's called iCanon, which is short for canonical form, which is the normal mode you have on a terminal input, where if you hit the delete key, it goes, takes out the last character and stuff like that. It processes all that stuff as a sort of local line editor until you hit return, and then that whole line gets sent in when you read. Now, those 2 modes, turning that one off and turning echo off, means that our program will just read them without processing and without echoing. So that's it's up to us to echo it, which I think is kind of what we want. If you wanted to do something like, a VI clone, VI has these commands that you type and they're not visible to you when you type them. They do things like arrow keys and so on. All right. So I think before we start on the actual IO control, I believe what we need is the ability to go to any byte in an array of bytes and either set or clear some flags. Now, I think if I go to the code we had, these 2, so notice it's and equal not. Okay, so you have a flag like echo, maybe that, I don't know if that's bit 2, I can't remember, but let's say it's bit 2. All right, so 0, 1, 2, it's 4 if you treat it as a decimal value. If you do a not on it, it goes from 1 bit set to all the bits set except bit 4. And then when you AND that, all those set bits mean those bits aren't affected, but bit 4 is actually cleared because it's ANDed with what's now a 0. And so that's a bit clear kind of thing. This one, or equals, that's more like a bit set kind of thing. Whatever bits are set in there, they will now be set. And if they weren't set, well, they're whatever they were before. Okay, and then these 2, these character things at the end, Well, those are this one is to set up to say I want no delay before reads, and this return it as soon as you get 1 byte. We may need this, we may not. I don't really know. Okay, let's see what else we got. Well, we printed it, or we looked at terminal IO. Terminal IOs.s. Okay, yeah. So it's input flags, output flags, control flags, and local flags. And then a line discipline character, and then followed by a bunch of control characters. All right. So I think, well, all right, going back to where we are. I think the first thing to do is to support something that clears flags on a given byte. So I want to be able to say, let's go back to to do, this is 0, 8, 16, 24. Byte 24, I would like to clear whatever bits get me down to a 0, 4 here. Okay, so it's echo and canon, whatever those 2 bits are. And then I'd like to clear the next one. Again, I don't know what those are off the top of my head, but I guess was 4, 1, now it's 0, 0. All right, but I think that's the low-level primitive we want. Go to an index, clear some bits. We might need set bits, but we don't yet. All right, so let's do that test first. It's just sort of a helper function. Okay, so instead of that one, I think what we want is test start. What was this? Like clear bits at, bits clear at, clear bits at. Clear bits at clears bits. Okay. Yeah. Okay, let's do a range act asserts. All right, and we also need a test running program in here. So we'll just kind of steal from one of the other ones. We'll start like that. And that's all kind of part of our test framework. So this is IO tests. And we're going to BL2 this. Oops. And we'll save those other ones. They're no harm right now. All right. So, well, I'm going to say if we... Let's make some data, and we'll just do it as characters, I think. Is that going to work best? I think it will be okay if I do lowercase a. Well, let's do cars just as a string. Okay, so I'm going to say, so I know this is 97, the character for A. And so if I clear the 32-bit, well, actually, maybe let's do this. Scares. Okay, let's take this one. So if I clear bit 32, it becomes uppercase, and if I clear the lower bit, it goes from a C to, I think we said it was an @ sign, right? So that should be good. Let's give this a label. L clear bits. Okay, so I guess we're gonna do a load address x1, do we want the pointer? I guess we need the pointer, the offset, and the value. X0 gets L clear bits. The offset is 1. If we're going to change the C, sorry, I should do the index. Oh, that's the index. And then the bits, I want to clear x2. I'm going to say OX. And this is where we wish we were Arabic and our Arabic numbers started where we are. Well, I'm going to clear the lower bit. So that'll get it down to a lowercase, whatever the character before lowercase a is. And then bit 2, 4, 8, 16, and 32. Does that look right? Well, except I can't put it in binary. 1, 2, 4, 8, 16, 32. Okay, now if I put it in hex, this is just a 1, and this is a 2. I'm not using loader to load the flags. No. I'm going to treat the flags. So well, I think I can just do a move. It's just simple constant going in. So I think this is all right. We don't need the address is the memory we're going to change. So we're going to say go to clear bits, go to the first character as opposed to the 0th is a C, do this, and then here we're going to call clear bits at. And then at the end, well, I could probably just do an assert equals string. Okay. Okay. So I think this is pretty well it. So we're going to give it the string to change, well, the set of bytes to change, indexed off it, reset bits 32 and 1, clear them, and then we expect to get this back. Okay. Yeah, I think we're okay. Now we don't have that name yet, so this is line to clear bits at. I'll put some commas in. X0 is pointer to memory, or pointer to byte sequence. This one index to change. X2 is and I guess it's just a side effect. It's not really returning anything. So yeah, I think that'll be okay. Oh, in our make file. Guess we'll need Unix functions. Well, it's really this. I don't know which of these. I don't think I need everything. Probably C-like. You seen it? Oh, maybe just those. All right. There we go. Well, I didn't double check we were clear, but I'm pretty sure we were. Well, okay. What I think I'm doing. Let me make sure this is what we expect. I don't see IO tests. Okay. All right. Let me go back. I'm changing 2 bits because I'm flipping the 1 bit on the bottom and the 32 bit in the middle. The 32 bit, like the A is, well, A is 65. You add 32, you get 90, 96, 30, 90, 97. So that flips it up or lower, and then I'm zeroing out the rightmost bit, so it'll go back to capital C, which is 1 1 on the bottom. But I'm going to clear out that bit. Oh, right. So it will become 1 0. Is that B, capital B? Yeah. So the 32 clears out the other, and 0 1 is 2, which is corresponds to B. So okay, you're right. I think this will be better. Okay. Where's our test? Okay, clear bits at is not global. I guess that's assert equal strings, which I mess up all the time. Reference and IO tests. Oh, doesn't have IO.io. Thought I had that in there. IO tests. Oh. Let's try that. Depends on the O file and IO.io. Okay. Okay, let's see IO. Okay, so it fails at least the way we expect. It's doing nothing, so that's fine. Okay, let's see, IO. All right, so I think the C code really contains the hint for this. How do you clear a bit? Well, you not it, and then you and equal it. Okay, so we're gonna have to load that byte, and then do some stuff, and then write the byte. Okay. Alrighty, so let's load the byte. Well, I know we got to do W's in there somewhere. What's on LDRB we used before? Oh, that's the value we're getting. The address is there. Okay. Yeah. So let's load W3 since that's not in our way. It's really X0 plus X1. I hope it'll let us do this mode. Okay. And then at the end, we should store byte W3 at X0, X1. Okay. Yes. Because otherwise you wouldn't be able to read a character at a time because they have odd addresses as well. The restriction, well, there's no restriction on these pointers. I guess the restriction is you can only read it into a W register. You can't read it into an X register for whatever reason. Okay, so now we want to negate X2, which I think was just a not, but I guess did we put that in arithmetic? The one file I don't have open? There's neg and amps. Max. Oh, it's logical. Not routine. MEN. Okay, so MVN flips a value. Okay. And I guess we'll just flip them there. And I believe it's just and. Well, okay, we got logical there too. And routine, just and. Okay. And so W3 is our byte. W3 equals W3 and X2. I don't know if that's quite acceptable to mix those like that. But I think it just ignores the upper stuff if there's any issue. Maybe these should be W's in the first place. I think that might be a better way to say it. And let's fix the test to that too. W2. Okay. Well, I didn't see any red. Okay, there it is. All right. Now, I think that sort of tests that we didn't muck up the other bits because otherwise the letter would be all wrong. Okay. But I think the test can maybe, let's see, changes character to local and moves it back. by 1. I guess that kind of says what it is. It should lower. Case. Okay. That should all be good still. All right. So let me get this in the to-do as well. Okay, so this. All right. Now, I'm not as sure. Yeah, I think what I want to do, I'm going to modify this kilo thing a bit. My theory is most of these don't matter for us. I don't even want to turn that one off, really. Post is an output thing. CS8, I don't even remember what that is. And then this line. And I don't think we need this to do what we want to do. Okay, I'm going to take off these. Okay. This is the code I think we want to write. We'll see if it works the way we want it to. It'll probably destroy my window. Let me just open a different one. Oh yeah, this is exactly what we want. Before it had that instant read, so it was just constantly reading, but this is waiting for us. Well, hello world. Okay. 10. Oh, we do have that 10 translation. I can do Control J is 10, Control M is 10. There is a flag for that. Is that the O post? I'm not sure. I think it is. Let's turn this one on. Nope. Okay. Let's go read the instructions. Oh, let's see. We had so much stuff open in the window yesterday. No. I think it's over here. Yeah. This example. Where was the write-up? Oh, man. And that's not it. No. No. Where was that thing? Is it here? No, that's Apple. Oh, I lost that link. Oh, man. Kilo. Maybe he puts the explanation up here. Nope. Um, I don't know where to find it. Oh, let's see. Let me hide this for just a minute. Well, I didn't see it. Well, we can do a search. I'll say kilo terminal editor term iOS flags. I think that's it. Okay, let's capture this. Okay. Control M. Yeah. ICRNL. Okay. Let's try that. ICRNL. Okay, let's make a new one. Raw.ci flag and equals not ICRNL. So what that's doing is it's turning off the automatic generation of a return for this. Okay, this should be 13. J should be 10. M should be 13. Okay, but it changes the printing too. Yeah, it's no carriage return. So, which seems odd in a way. Well, no, what it's yeah, because my code just says print out back whatever blah 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 \n, and we're doing this in a terminal mode that does not have a return attached to that. So it just does a line feed. Now, whether that's I don't know if that's worth it to us. I mean that new line to just print out a new line is kind of nice. The other alternative is you just require that they put \r\n like a Windows programmer. I think we'll leave this one out of it. Okay. I don't think we have to distinguish. Like we don't have line feed keys on most keyboards anymore. Yeah. All right. So I'll run this one more time. And notice I still have Control C because if I turned off all those flags, I wouldn't be able to do Control C to get out. Let's do CC. And then I just wanted to, whoops, did I not get rid of it? Oh, have I locked it in this stupid mode? Well, I was interested to see the arrow keys. Escape 91. So escape bracket A, escape bracket B is down, C is right, and D is left. Page up, page down don't seem to do anything. Forward delete, backward delete. What else we got? Well, control A, B, C. Okay. All right. So let me close this window because I think I've trashed it. Let's repeat that with a new window. CD here. CC kilo. That's yeah. Okay. Good. All right. So now our before and after has changed, therefore. So 026B, that line's the same. 30 is the same. This 004B is the same, but we have C304 instead of CB05. So CB05 goes to C304. And let's just play in the to-do. All right, and if I write that out, C is 1011. That's 8 plus 2 is 10. No, C is 1100. 8 plus 4 is 12. 10, 11, 12. 0, 101. Oops, that's C. 1, 2, 3, 4. B is 1011. 8 plus 3 is 11. C 0011. Okay. So if I compare these, I can see I've changed this bit, the CB flips one bit. I guess it flips the fourth bit, or 0, 1, 2, 3. You know, the 2 to the third is 8. No, is that right? That should be. Oh yeah, 1, 2, 4, 8. Okay, so we want to change the 8, and then we want to clear the 8, and then clear the 1 bit. Okay, now I don't know how to express this as well as we want, but it needs explanation. I guess that's what my point is. So the term iOS structure contains, let's go back to that. This input flags, input, output, control, and local. Followed by a number of characters. Line discipline and other control. Okay. I don't know if I want to put this before and after in there. Maybe I do. Oops. Well, I'll put the whole thing in. I don't. Do I get this automatically? No. Okay. 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 So this is, let's make some constants. So I think we want to say the index of the, well, we got to figure out which byte is the right one. I don't know which file to reference for these. Is it kernel term iOS? No. No. I don't know how we know what those are. That's our syscalls. Oh, and I think I saw something, yeah, sig action. There is no signal per se. I don't think. No, that's not it. Nope, 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 nope. Okay. Well, okay, termios.h. Do we not have that open? There's termios.h source. Oh. Okay, O flag. I flag. No. We should see echo and I canon somewhere. Okay, which flag is it? L flag. Okay, so I think I'll reference that. Okay, but I think what that tells us is echo flag is octal is starts with a 0, right? We're in C, so that's really a 4. And then where's the canon? Canon is just a 2. Okay. So let's take those. Echo is 4. Canon is 2. As kind of our first guess, we're gonna make some. We'll do some prints and make sure C agrees with us. That's octal 8. No. Yeah, that's octal 8, isn't it? 8. Well, let's make sure C agrees. So we'll go to our kilo. Okay, I canon equals 256. Echo equals 8. I think we said 8 for that. 256. Yeah, we can just turn off one at a time. Let's go back to that term iOS, though. I don't think that matches that. I can. Is 2. Oh, let's look at these then. Oh, where did I put my bits? I think that was the 2. So 1, 2, 4, 8. That seems like that's the echo flag. That seems like it's a 1 in the next byte. But these are hex, right? So 2 of them is one 256 bit or one 8-bit value with 256 options. So I think iCanon is really 1. Well, I'm going to make clear that's an approximation. Can't find Mac specific documentation. Yeah. Well, I think that looks like a 1. Now, the other one is more easy to get. So 0, 8, 16, 24. 25. 0, 8, 16, 24. Okay, so byte 24, byte 25. Okay, now the bytes are in the wrong order, you think? Oh, you think C3 is the low byte and that's really the canonical one? Well, let's take them off on this side first. I mean, I'm really a bit puzzled by kilo. I don't see how any of those are byte 255 or bit the 128 bit. That's what it was, right? Ugh. 256. Now wait a minute. How do you set the 256 byte bit? Oh, it's because they're in. Oh, I get you. Okay, so if this is 1248, 1632, 64, 128. And then 256 will be the bottommost one on that one. Okay, but so I think if we were treating them as words, we would do that. But it's the lower bit and the high order byte. Right. I don't know. Would we be better off? Yeah. So I don't know. I kind of don't mind zapping the bits, but there's a lot to be said for matching the flags to the values that we get from other sources. Okay, let's I think we want index of L flag. And that is 24 bytes later, but we want the whole word. And this is 256. Is that 100? 1248, 1632, 64, 128, 256. Yeah. Okay. So, yeah, I think let's change to that. Okay, so I think this. So the clear bits. Let's change the way this works. Let's do quad. OX107 doesn't matter. This is the one we're going to change. And I think let's just do this 20005 CB. Okay. And then the expected bits is another quad. OX200 200005 CB, but then what is it supposed to become? It's supposed to become 04 C3. Okay. And then the thing we're changing is really 1 and then 08, I think. Does that seem right? And then this is now move to the second word and load address. Well, okay, so get the contents of the word. This one's the correct address, but we still need to load it. And assert equal. Yeah, I mean, definitely. I'll just bits. Okay. And this, that's a quad, that's a quad. O5CB becomes O4C3, if we do this right. Okay, now the W's, I don't want this to be a W anymore. I want an X again. Okay, because it could be any sequence. If it's too big, we have to manipulate it, load it in parts. Okay. I don't know. I think I'll just say bits to flip. Okay. Right. That should fail. Good. All right. I sure wish this was in hex, but oh well. Life's. We talked about the possibility, but I just haven't made it a priority. Okay. But we should be able to get it to work now. Load RB. Well, we just want to do load R, like you said. Let's load X3 with whatever's at X0 plus X1. Right. And then we're going to move, this is X2. X2 is not X2. And X3 with X2. And then store X3 at X0 plus X1. Okay, so we load the word, we negate the flags, we and them, and that. Okay. Boom. Okay. Let's put this in our calculator. I think we still have that up somewhere. Yes. Base 10, clear, paste. O5CB. Is that what we started with? O4C3. Well, that seems very much like it doesn't do anything. X0 is L clear bits, right? Offset by 8. X2 is 108. There we go. Okay. So let's say we did ACP. Make, what do we call that thing? Clear bits out. The assert is it's loading the two values from the memory and comparing them as simple values. Yeah. So, yeah, I just screwed up. That line was 1, but based on characters instead of 8 based on words. Okay, where's that leave us? Well, I think it leaves us better because it's pretty clear we can zap this word with the right thing. So his offset should be 24 bytes, which is good. His flag is 8 and 100. And does that match our test? Yes. Okay. So I think the result of it is going to be moderately readable, put it that way. Now, I don't think I'm going to... I don't think there's a test to write for the actual thing. It's only going to apply if you're actually running it at the terminal. Okay, so we got a little bit of just plain old coding to do here. Kind of without a net, I guess. All right, so what I want to do is make a function that says enter raw mode. Make a global. Okay, and the enter raw mode function is going to look a lot like the C stuff. All right, so it's going to have the prologue because we will call something, and the epilogue. Okay, and let's go back to our C program. And we have an assembly playground program that's it too. So we do tcgetAttr. We got to have some address, somewhere to put it. Now, I'm not going to worry about fixing it. Yeah, it'll be easier to set more flags or clear more flags. All right. So I think we need to load our term iOS, zap it, and then store it, and then we're all set. Okay. And let's take what we did in the playground. Yeah, this stuff is, well, this is accurate, unfortunately. Okay, so io.s, let's just start getting the pieces in. All right, now we had L input buffer, whoops, in here. We'll get a better name. Well, I guess I need to do this stuff too. Let's make this L term iOS. Yeah, let's just do that. Okay, we'll have to explain this 4048 code. Okay, so that was that. Load address, then we do this and that. Okay, so this is call ioctl to get terminal attributes. Okay, and then the code OX40487413. And I do want to explain this thing. Did we do that? There we go. I know we put a message somewhere. Um, oh, maybe it's in our PowerPoint. No, I remember writing all this stuff down. Okay. I think we can recover it. All right. So, 40. Four eight equals 72 base 10 equals size of term IO struct 404874 equals lowercase t equals go to say it's terminal control. And then 13 equals 19 equals code for get attributes. Okay, so this is the get. All right, and so that will fill up this structure with that. Now, did we do? I don't think we did the rest of it. No, I just exited. Okay, we may have to do a little tracing here, or a little dumping, I guess, more like, for the right one, the set adder. Now, I know we've got browser stuff for that. TC get adder source. Oh, no, in our kilo, we can see it. Set adder. Standard in file number. Okay. TCSA flush. No, we're going to need more. Okay, let's go back here. See above, term iOS. Okay. All right. Okay, then we got to do our edit. So I guess I can outdent this a little. Okay. Set echo or clear. Echo and iCanon flags, which is something which we haven't determined, and then call ioctl again to set terminal attributes. Now, a thing we're doing is we're potentially destroying I guess we're destroying the terminal settings. And I did a little research on that. Let's go back here. Just somebody asking, like, how do I handle SIGINT in Apple M1 assembly code, which is exactly the question we have. So So the way signals work in Unix, the operating system can send a signal to a process. The process has a little table, 0 goes to this, 1 goes to that, 2 goes to that. And in each slot in the table, you can put the address of a function you want to call when that signal gets sent to it. And so sigint corresponds to interrupt, which is Control C usually triggers that. And we would like to install a program in there to detect that and reset the terminal attributes. We have not done that. I don't know if we have to. It's going to depend how annoying it is to have to deal with them, but we'll see on that one. In a way, it's like this is another one of those things. If I were doing this for production, there would be no question in my mind. I would have to go debug and trigger all that stuff. Okay, lget headers, lset headers, yeah. I don't mind them in the module. It's just kind of weird to set them up. Well, I don't mind doing what we did for Unix calls either. Let's close some of this. This one. Right, we did Unix read. You still had to set up all the arguments, but then we encoded the service call and all that stuff. Yeah, so maybe a macro for those would be progress here. But the macro is really only this much. But that's okay. Macro, well, I don't know. If that's the macro, that's all there is to it. IO control input x0 equals file descriptor, x1 equals well, it's really a command. It's really annoying too, but it is command. X2 is address of term. We'll just say term iOS struct. Could be a different struct in general, but we're not worrying about it. Okay. Oh, I can make it arguments. I don't know. Is that better or not better? Because it's got to be those. It's got to be in those registers. So it's like you're gonna set them up in those registers. Okay, well, take this for what it is now. Slight improvement. Okay. Now, yeah, that would be good. Sorry, macro get, well, terminal controller get adders. That's kind of the C version of this. And we want to take, I think we just want to take that memory address, struct. Okay. Oh, actually, file descriptor. Struct. Man, that's good enough. No, I want to get this right. Okay. Okay. Now you're right. This becomes the much nicer get tc get adders 0 and L term iOS. Well, we may as well do, okay, how about get terminal attributes? We get little enough love in terms of naming things. Let's do our own naming. Okay, yeah. All right, yeah, I think that's an improvement. And then this one is going to call set terminal attributes. And I don't know what we'll go with it. Well, something will be L term iOS. Presumably it's the same file descriptor, but there may be another code in there. And we'll get that as we go. Macro set terminal attributes file descriptor. Okay. And now our work. Okay, we know somewhere, I think maybe these can come down here a little because they'll be more explaining to this. Okay, enter raw mode, sets terminal mode to raw-ish. Clear, well, clear echo and iCanon. Okay. Now, fortunately, we have a routine for this. Clear bits at, right? So we're going to set up this stuff. All right, so X0 is the address of the structure. X0 is L term iOS. X1 is the offset. And that's 081624. And X2, well, interesting. I almost, oh, wait, not using my definitions. Index of idle flag. And then I think I can do this. We'll see what the assembler thinks. Echo flag plus I canon flag. Otherwise, we'll just manually OR it together. I don't think we have a vertical bar to OR them in, right? But let's make and see what complains. Unix ioctal, unrecognized. Interesting. While in macro instruction. Oh. Unix underscore ioctal. I copied it, I think. Right. Oh, we have to, I think this thing, does he use defines? Let's find somebody else who needs Unix. Oh, we didn't put it in. In our make file. io.s depends on Unix functions now. Macros and input macros. Now the IO test out shouldn't care. Yeah, I think it just doesn't rebuild because I didn't have that listed. No. Unrecognized instruction, Unix ioctal. IO certainly depends on it. IO tests. Is it in test macros? Well, it's in macros. IO tests. Depends on macros. Yeah, we don't have to worry. We're using independent bits, so a plus should be the same, but it's kind of weird that it has to be. However, he depends on macros and test macros. IOTest.s. IO. Who complains? IO.s. Unix functions.macros. Did I not include it? I did not. Okay. Everything's passing there. Nothing blew up. Yeah, a little slow there. All right. But this did not complain, so we can do that for our flags, and now we call BL clear bits at. Okay. So I think that's okay, but we have to figure out this echo the output or set terminal attributes. My guess is there's probably some bizarro constant that's just like this, except it's going to be not 48 or not 13. The size should be the same. T is going to be the same, but this, I don't know, code for get attributes. Maybe we can find that real quick here. Get attributes. It's more of a, I mean, I could swear we had something up that should show us. Right, it was that thing with the IOR and IOWs and all that. I thought I left everything open. Oh, here's some TC get S. 5402. Oh, okay. See, they have 1 and not 13. Well, what's 13 is D? Again, we're not on the Mac side. I don't think this one will tell us. I still cannot believe you just can't click on a link and get these things. If they are, I don't know. I would just expect this to totally be in the documentation. Okay, this is the actual system calls, but we're doing a sub call. Is there get adder? Get adder list, that's different. That's file, I think. Okay, that's not it. What else we got here? Somewhere I have individual pages open and something. Notepad. Texted it. No TC get adder. Well, yeah, where did we find this? It was something like this. Get special characters. Maybe this is it. 8 and 9. But that's not right. Is it? T8, T1. Well, I don't know. Maybe we just make a guess. It's 1 higher. X13 is 16 plus 3 is 19. Just when you need it, it's not there. TIOC get P. That does not really sound quite right. GTTY STTY. Let's look for. What else we got open? NC term IOs. No. Yes. TC get adder. That's the flags. We got a lot here. Okay. Bunch of flags. Control characters in the array. Okay. Input flags, output flags, unimplemented flags. Those aren't relevant. Those are all individual flags. Three was read mode, 4 was write for print. Yeah, I think let's make a well-educated guess. If this is 13 is get, let's try 14 for set. And then we'll try it, and then we'll do what we have to do to. Oh no, we're still gonna have to run more to find out, because this thing has an extra argument. Set-adder has this flush thing, and I don't know how that's getting passed in, because this is a C routine, not the calls. But we found that other constant when we trace through the get string, the get adder. So I think we'll take our break and then come back and trace this, or at least dig through the OBJ dump and see what it calls and what argument shows where, and if we can find a similar constant. I think we'll see how it works. I don't know. IO control. I don't know. It has a command, but yeah, we'll see. Anyway, let's take 3 or 4 minutes off and come back and give that a go. Welcome back. All right, let's go check that dump if I can find it. There it is. Okay, now I think we just want a.out. That's what we just ran. Okay, and the routine is, well, there's main. There's TC set adder. Okay. X9 SP. Yeah. Okay, well, I don't know if that's TC set adder or not, because they're all over the place with these. I guess we got to go look at our main. Enable raw mode. The last thing it does. Enable raw mode. BL die. $3D98. This is weird code, right? I mean, it's branching to the next instruction. Okay, where's the BL? There's die. Oh, here's another BL. Enable raw mode. 3DC8. I don't get it. That's the kind of code I mean, like a people optimizer would take that out, I would expect. It appears to just be branching. $3DC8, branching to the next instruction. T set adder plus 3ED8. I don't know. See, I don't know why this one doesn't call die at the end, because it seems like it should. Okay, I'm gonna run this. We may get screwed by it. Minus B TC set adder. Okay, so set adder. 70 bytes for whatever. Well, no, 7 times 16 bytes. We store x29, x30. And 60 bytes. X29 is SP plus 60. Okay. That's I think that's stack frame stuff that lets you like set up a pointer to the beginning of the variables, and then wherever you are, whatever you do to the stack, that pointer is still correct. Add 2060 check stack guard. Well, this all sounds like kind of verification stuff. Move I 2D V0. Store the pair Q0. Why would you store the same thing twice? I really don't get this. You're storing Q0 all over the place. 19B68 is 1. We haven't got down to the actual call yet. CBNZ. Well, I think that's... No. I don't know if that's the -8 or not. DC. Store X2 contents of SP. BLI octal. Whoops, 8048 7414. Oh, yeah, good point. 8048 7414. $8048. Interesting. Okay. Wait, 7414. Good eyes. Yeah. I don't know what that second change is. 80 equals 8. 8 times 16. That's 128. At least that's consistent. 74 is still terminal. It's 20. Yeah, could be. Write mode. Okay. Well, there's that TCSA thing too, but we looked that value up and it was just a 2. I don't think that relates to this, but that does leave me wondering. Okay, if that's ioctal, X2 X2 into the stack pointer. I don't know what that is. Okay, X1 gets X8 X ORed with 1. I don't know. W8 gets 7414, 8048, 7414. Then this gets that X ORed with 1. X2 gets the contents of the stack pointer. I think W8 is just a temp. I don't know what that is. 6811 DC. Oh, now there's a 2. Well, that's kind of the same, right? There's 7414, 8048. X1. X8 or 2. We may have to do this to it. Yeah, I don't think that's. I mean, the 2 should come down here, should be a 6 instead of a 4 or something. But we'll see. Okay, so the body has to be kind of like this. Does X2 seem like it's the terminal structure? I think it might be if they put that first on the stack. That's back in the code. He doesn't really declare it there. He does do this pretty early, though. Yeah, I think that must be this raw. All right. So kind of starting here, we move 8048 in there. We OR X8 with O2. Or maybe with 1. All right. And then X2 is that address. That seems similar. Well, we'll give this a shot. Okay. And then where we call this, well, this kind of affects our input thing. Unless you just turn this on when the user's input is supposed to come. Yeah, it's the flush flag, which I think, I mean, based on what I'm seeing here, right? This sets it to 1, but up here they ORed in 2. 11 DC is this and that. So I think this is the. I don't know, it's a little hard to tell. We should see a store X2 SP somewhere. Load X2. That's what's weird to me is I don't see that store like right near the end here. Well, it could be a STUR. SP plus 8, X8, SP plus 96. I don't know. I mean, the only thing yeah, I don't know why. Well, we saw it as a 2 somewhere in one of those header files. But the only thing this flush thing does, I believe, is when you set the, I think it's setting it up so it's either when you set it or when you exit it, it's gonna clear out any input buffer you typed. So if you typed blah 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 and hit Control C before it could process it, this would force that extra stuff to flush out. But I don't think that's quite gonna matter to us. Okay, my theory is I think let's just call enable raw mode and see what enter raw mode and see what happens. Maybe I can do it from the playground. All right, so start. This stuff is all sort of into raw mode, or it's encoded there at this point. Okay, so I need to link it with IO. Make file. Yeah. Yeah, you would think they'd either, yeah, yeah, I don't know if it's a sequential number or if it's, I mean, if it's sequential 0, 1, 2, right, that kind of makes sense. 0 doesn't make sense as a power 2 for anything. So, yeah, it's probably just a count. I'm not sure what the point is or why it would show up two different ones here. All right, let's see if we can make this work. Quit. Yeah. Okay, and then if we do make unit test, was it demo or playground? Playground dot out. Enter raw mode referenced. Oh, I probably didn't put in the globals. No. Global enter raw mode. Enter raw mode. Enter raw mode not found. Start. See like, oh. Make files wrong. Oh, it's unit test playground, not unit test demo. Well, we can call it in our REPL. It's a little more drastic. Excuse me. I kind of think this is the wrong place, but I think it's going to mess up the REPL itself that we really need to turn it on and off before we go in there. But make. REPL.out depends on IO.o. Eval and REPL.o. Oh, REPL tests, yeah. Okay. Guess I'll do this over here. REPL.out. Hmm. 7414, 7416. Okay. Well. Well, it didn't break anything, but I don't know that it did anything. Okay, I think that now is redundant. Okay. Yeah, so I mean, I think we're taking now then by default. I mean, her problem seems a little more, a little further away at this point. Like, how do I get this work? Know that it's working. Well, the real way. We didn't do this, but there is a status code coming back from this thing in X0. I guess I could call print num. Is that in here even? Dot print. So it didn't print anything, even though it supposedly ran this code. So what does that mean? Unable to resolve. Enter ROM mode. REPL.out should depend on IO. Depends on IO. Why is that not? Yeah, no echo should mean no output. Oh, did it set it? Well, no, it didn't even find it yet. So, but no output would have been a good sign even. Although maybe not. Maybe it can't detect it here. Okay, let's just run. But it doesn't seem to know about inner raw mode. So how would the REPL be calling it? But I do this and I get stuff. So that seems like I'm not in that mode. So I guess look back here. REPL.o, REPL tests dot out depends on IO. REPL.out depends on IO. So it should have been built with it. Make REPL.out. Okay, so the LD to make REPL.out, it needs IO.o. Now I declared it global. Try this again. Grr. Oh, I'm running the wrong thing. There we go. Okay. Now run. Allow. Skip that. Skip our setup. All right, now do a reg read x0. Okay, it's not -1. That's a good sign. Okay, step. Where is that? Step. Okay, we're back in REPL inner raw mode. We're doing this, enter P. Okay, get that field. X16 is OX36. Well, that's probably not. Oh no, that's IOCTL. Yeah. Serves 0. Reg read X1 is 0. So theoretically, it passed. Now, let's do NI, which should skip over and print something. It did. Okay, let's try this on the real side then. /REPL.out. 0. Okay, so why are you... Oh. It did. I think. Yeah. Okay. Oh. Something happened. Yeah, so the 0 printed, so it means set header succeeded. I typed A and it immediately returned because now I'm in this semi-raw mode. Now I don't know what the bus error is, but okay, so there may be, I don't know what I typed here. If I type Control C, let me try it again. Control C, and it quits. So this is reflecting that we're more in cbreak kind of mode because we still crash our app on Control C or exit our app. So, um, I guess what I don't know, I'll do this again. A, B, boom. A, B, C. Third character is blowing up. Okay, but we can take that out. Okay, this is good. I mean, it's progress of some sort. Whether it's the right kind of progress, I don't know. Let's take this out here. I don't think we want that really, but I want to know if this thing still does that. So let's do a make. I think if I say reset, then it'll flip those modes back. Okay, so /REPL.out, A, B, and it's not. C crashes. Do it again. A, oh, it called it. Wait a minute. Why did it print that 0? If I didn't call enter raw mode. Did I not save? I did not, apparently. Or I didn't make or something. Make. What's going on? Okay. io.s does not. I just deleted this print num. I saved. We did a make. Does the IO test pass? That'd be worth knowing. Okay. Oh, we just do a clear bit test. Yeah, that's nothing to do with IO really. Okay, so let's make REPL. He didn't print. Okay, I don't know what happened there. A, B, C, no, it's D, C, E, A. Okay, so that's kind of a good sign. What's going on here that I wasn't getting this? Which way is it going to act? A, B, D, C. Okay. It's something in that. All right. So let's make sure where we are. Make passes. Okay. Whoops. Something red up there. Nope, that was that. Okay. Let's see. Added enter raw mode untested. Or at least manually tested maybe is a little more honest and fair. Although something's going on. Okay. So when the REPL does a read in raw mode, it just gets whatever the character is. And this is in the, I don't know where that book even got to. That threaded interpreter language book. One of the pieces they did in theirs was basically they made their input line kind of work like the Unix input line. But they started from the equivalent of raw mode and they, oh, it's a delete, remove the last character. It's a return, send it in. But yeah, but notice it didn't crash. Do we still see it? I mean, I did A, B, D, B, C, D, it was only while that mode was on. So I'm not sure what that was. I don't think I was. I don't know. Could I have hit a return in there or something that didn't show up visibly? But I think the reality is we don't really want to be in raw mode. It could have been the printing, but here it's clearly not anything about the dictionary or the REPL that's doing it. It's got to be something in there. But I think we need to kind of keep track of raw mode and like I don't know. It seemed consistent about dying on the third call though, right? I mean, I don't think I did it wrong that many times in a row. But at any rate, I think we probably need to keep track of the raw mode and flip into it when the user initiates a read. Like if they write a program that says read this letter and do something, then we should go into read mode when they have their read statement, and we should exit it when the console is trying to read. So I think we're going to have to, well, I mean, I put off the signal thing about how do we detect Control C and restore the environment, but I mean, we have a manual way to do that, and that reset should do that. But what this makes me think is we need to exit raw mode as well as we need to enter raw mode, which means we need clear bit just like we had set bit. Okay, so I think in the time remaining, let's get set bit at working, and then we can write exit raw mode, or yeah, exit raw mode would work. Okay, so yeah, let's do that much. I'm imagining some sort of flag that is set when the user tries to executes their read statement, which we haven't written yet, and then the REPL, when it wants to read, turns that flag off and it gets the normal, it exits raw mode. Okay, let's take that out. Okay, so I think we can, well, let's rename this lbits cleared and lbits set. Oh no, let's not. Let's make our own data. Okay, if you start with 017 and I guess it's kind of the opposite. If we start with 4C3 and go to 5CB. Okay. I think this will become almost the same then. Okay, we're going to call L set bits. Bits to flip. Yeah, this is going to be an instruction easier. set bits at. Load address clear bits offset by 8. Yeah, you got to do that. Well, this is L set bits and L set bits expected. Okay. Let's put this test in. And then IO needs a routine. All right, that fails. Okay, so we load the word specified at the address. We don't need MBN, and we just need OR. All right. And let's add some comments. Pointer to word index. Well, it's really offset from word. I can say this, yeah. Bits to set. I'll say X0 here. Maybe byte offset, just to be clear. Okay. Okay. Yeah. All right. Now, well, I guess I'm going to do the same kind of thing. Yeah. We've got 10 minutes. Let's exit. Raw mode. Okay, now we got to pay for something here. LSL3 addressing. You might be able to. Yeah, that'd be worthy. Well, let's do it safely. Okay, so this is word one. This is word one. That's offset 8. That's still correct. That's correct. We're kind of checking the 8s. All right, now we should get 2 fails. I can't read fast enough. Input. Oh, okay, good. All right. Good. Okay, now, what I'm worried about, we can see it in the C1 actually. We have raw equals original term iOS. So this one actually does a bit copy, creates a new space for the one to modify, and then leaves the original lying around untouched. Okay, and I think that's kind of what we should do as well. It's probably a little more than a 7-minute job, but our our data, wherever I put it, let's move that down to. Okay, we have term iOS. Let's make that original. Okay, that should not do anything bad. Well, if I catch them all. Oh, there it is. Oh, there's another one. Okay, so this was really rename L term iOS to L term iOS original. And I think just to be really careful here, let's do that a couple of times. Okay, so we need to Right. I guess the way we're doing it now, it doesn't matter, does it? We zap it back. Right. So the way the C program does it, where they copied the whole thing, in a sense, that's safer for the set attributes. Sorry, yeah, the original change to that mode. Going back to it is just copying the original, and you don't have any assumptions about what you changed. But this one does, but I don't think that's terrible. The name change is okay to me. So I don't know what is maybe. Okay, I think we have two paths for tomorrow then. One is we either keep some sort of flag around so we know the REPL knows it's in raw mode and exits it when it's time to read for the REPL. Or we implement the simple line editing, really just delete and making sure you don't delete past 0. We could implement that in our REPL and just live with, add the echo, add the checking or whatever. I don't have a feeling for which path is better. So it's either track the mode and restore it as needed, or it's just set it raw and live with it. So I think that's our decision tomorrow. We might end up trying it both ways. I don't know. We'll see. If you wake up with brilliant insight, or at least any insight, we'll take advantage of it and see what we can do. But I feel like we're kind of close to having this set work. We had that weird stuff. Only line 208 is needed. Yeah. Right. Is that going to be enough? Well, no. We'd have to copy it if that was going to be the case, right? Yeah. Oh, if you keep a copy, you don't need to restore it. Yes, that would make that easier. It makes it a little more robust because we're at least theoretically operating from the original one, rather than saying, "Oh, I know how to undo exactly what I did. I'll just flip these flags back." It's not unbearably wrong either, but it might be nicer. I don't know. But I am puzzled why that third entry seemed to crash in raw mode. That suggests something else is going on that we're not quite on top of. So, I don't know. Call get attributes twice, entering raw mode. Well, yeah, that's true, right? I mean, we don't even have to call it twice, do we? If we just call get attributes, aren't we back to where we were? Oh no, we're getting the current attributes. Never mind. Okay. I guess that's it for today. We'll see you tomorrow. We'll resolve this thing on reading. We'll probably make some sort of read command for programs to use, the 10th language programs. And I think once we have those in place, we're ready to start writing our Hangman app. All right. Have a good night. Next time is 2 to 4:30 Eastern Time, 6 to 8:30 p.m. UTC. And have a good evening. Take care. Bye-bye.